Here we want to write V as the sum of vectors from a set of vectors and their orthogonal complement. Okay, so let's start by finding what's in this orthogonal complement. So if the vector A, B, C is in that orthogonal complement, that vector dotted with 1, -1, 2 has to be 0 because it's orthogonal to it, which would mean A minus B plus 2C is 0. Additionally, if it's orthogonal to the second vector, then when we dot it with 1, 0, 0, then we get A is equal to 0. So that's equal to 0, which means that A is equal to 0. Okay, so A is equal to 0. And so B is equal to 2C. So if we let C be parameterized by T, then B is equal to 2T. And so the vector that we're looking at in this orthogonal complement is 0, 2, 1 times T. So that's the vector that sits in this orthogonal complement over here. So this is perpendicular to both of those vectors. It's also the only one there, which makes sense because in 3 space, 3 vectors should do it. Okay, so our vector V, 3, -4, and 6, we want to write as a combination of this vector. So we'll call it alpha times vector 1, -1, 2, plus beta times 1, 0, 0, plus gamma times 0, 2, 1. Okay, and so if we look at this, 3 has to equal alpha plus beta. -4 has to be negative alpha plus 2 gamma. And 6 has to equal 2 alpha plus gamma. Okay. So if I add the first and second vectors together, or first and second equations together, I get, oh, that won't be any good. I want to, well, let's double the second equation and add it to the third equation. So putting these two together, we get -8 minus, is equal to -2 alpha plus 4 gamma. 6 is equal to 2 alpha plus gamma. And so when we add those two together, our alphas are going to cancel. We're going to get -2 is equal to 5 gamma. Or gamma is -2/5. Okay. Knowing that, we can figure out what alpha is. So 6 is equal to 2 alpha minus 2/5. Okay, so 6 is 30 plus another 2 is 32 over 5 is equal to 2 alpha. 32 in half is 16. So this is going to be 16 fifths is equal to alpha. Okay, and knowing that, we can see that 3 is equal to, from the first equation, 16 over 5 plus beta. And so beta, 16 over 5 is 3 and a bit. Beta must be negative 1/5. Okay, so how do we write V as the sum of these vectors? V is going to be first vector is 1, negative 1, 2. It's going to be 16 over 5. 1, negative 1, 2 plus beta, negative 1/5 times 1, 0, 0 plus gamma, which is negative 2/5 times 0, 2, 1. And so that's vector V written as the sum of vectors from this set and from the orthogonal complement to that set.